today class we discuss. So whenever you are doing this type of problem, you have to go through the data is very important. Is correct? What are the data is given? Like the thickness is given, or area is given, or load is given. That is the factor is. Okay, that is the following thing. Okay, you just consider this data, then you are substitutes. Okay, class is discussing about how to solve the type of problem. So the example of few examples. Okay, so first of all, we consider if you are given as a problem is taper problem. So for the taper means the one end is length is very high, the other end is very short. Okay, the opposite corner get joined together. That is the problem is called as a taper like the problem. Okay, so first of all, whenever we are analyzing the FEA problem, we have to discussing, we have to convert the element in a symmetrical form. That is the form of important. Okay, so that's why we have to, this taper problem, we have to convert as a symmetrical form. Yes, the symmetrical problem means what? Is like a square rectangle. That is the mean of. Okay, so what I have to do is the length don't change this problem. Okay, so then I have to convert this element into according to our size is given. Okay, where is the load point actor? At the center. So the center is equally divided the top and bottom. Okay, so then what happened? Means the length is I have to catch here. This length also I have to catch. Then what I have to do? Second step I have to consider. Okay, up to this 300 mm height. Then rest of the data I joined together. I got the two elements. Okay, so here how many elements are there? Means there is a two elements are there. That is the element 1 and the element 2. Then respectively you have to consider the load numbers 1 and 2 and 3. Okay, then after that you have to substitute the load where is the actor. Okay, where is the load is actor? Is at 2. Okay, the 2 you have to substitute load. Okay, then you have to apply the boundary conditions. Okay, so similarly we don't have to give as a area. The last problem we discussing. So they give the area of the respective element, but we want to find out the area of the respective elements. Okay, so that we have to first find out the element 1 and the element 2. What you have to do is you have to first of all you find the node 1, the area node 1 and the area node 2 and the area node 3. Okay, so first we have to find out the area node 1 means is called as, that is the length into thickness. Okay, this length and thickness is given. You just product them, you got the answer of area at node 1. And similarly area at node 3 also similarly you product with this length into thickness. And what about the area 2 means this is the average you have to take here. Why? Because this is the unknown length, that is a combination of 150 and 75 mm is done. Okay, you have to add them and divide by it. That is called as average method. You calculate the area at node number 2. Then we find out this case. Okay, after that only once we find out the area node, then you have to substitute as a what is called as element area. Okay, so what is the element area? So you add them and divide by 2. Here also add them and divide by 2. You got the area of the element 1, area of the element 2. So this is the formal things for this problem. Yes. So first of all you convert this taper into symmetrical problem. Okay. The symmetrically you convert and then each node area you have to calculate. Then we have to substitute as a area of the particular element. That is the area of 1 and the area. Then after that what we have to do? So again I'm asking what is the displacement of the displaces. Okay. So here the two displacement is factor is correct 2 and 3. Okay. So I want to calculate the displacement here and here also. So this is the element 1. I have to, there is node 1 I have to fix it here. So first of all you calculate the stiffness matrix of the element 1 and stiffness matrix for element 2. So the what is the formula? Is like K E by L 1 minus 1 minus 1 1. Yes, correct. So then we have to substitute this data according to our problem. Okay, you got the element of the stiffness matrix. Similarly, then we find out the element 2. Okay, element 2, then we find out the K2. That is A2, E2 by L2. 1 minus 1, 1 minus 1. So here E is nothing but n smallest of the particular element. Okay, area also is a given. We find out from just now. Then we have to assemble them. That is very important. We have to assemble them. The assembling point is very important. Is correct. So you add the 1 and 1 and 2 and 2, 3 and 3. Okay. If the data is not there, you consider as a 0. Okay. Then what do you have to do? So then we go for the force matrix. Why? Because my general matrix is what? F is equal to K into U. Okay, you applying the data as per the data given your problem. Okay, and also substitute the boundary condition. So where is the fixed point here? The 1 is fixed, so that the displacement is 0. You have to eliminate the corresponding rows and columns. Then rest of the data, so you have to assemble them, and by using of calculator, you calculate the unknown displacement. Okay.